Hello everyone and welcome to another MoTeC M1 training webinar. This is a continuation on my series for the initial setup workbooks, and today's specific worksheet will be the injector configuration. So as always, I'm just going to go over to my M1 ECU, which I have set up on the bench here next to me. I'm in my initial setup workbook and I'm on worksheet number 8, which is the injectors setup. I'm going to do this a bit out of order, so bear with me. The first thing we can see up the top here is our engine charge cooling gain. Now I have given some idea of this in the original engine details webinar, and this is something that we're going to have to discuss a bit more in once we get to tuning, but this is the same number as was in the engine details setup. We've sort of, again, like the other webinars, I've sort of explained that every now and then we've got some numbers that will turn up in more than one place. Doesn't mean they need a different setting, it just means there's more than one place to get to it. One thing that we have available on this page as well, which will become more useful once you actually have your injectors set up, is a test mode. What we have here is similar to our earlier ECUs, is we've got what we can set up here is an engine test speed and also an engine test output. So we can actually choose one of the outputs, say the peak and hold injector number 1. We can set an engine test speed, so maybe 1000 RPM, and that will pulse that injector as if the engine was running. One thing to just be aware of here is it actually more or less bypasses everything else in the ECU, and the ECU will act or use that injector output as if it was at that engine RPM. Now the one trick is just make sure that once you finish the test that you reset this to 0, because by having any RPM in that parameter there, it actually changes the mode of the ECU. So if you leave 1000 RPM in there and then go to crank the engine, it won't fire up. Okay, I'm just going to go a bit out of order here. So the next thing, just to keep things simple, is the injector output resource. So we're basically just saying here for each cylinder of my 4-cylinder example here, which actual output are we going to connect that to. Now previously in the engine details I'd already set the top dead centers of the cylinders so that the ECU basically had the firing order of the engine. So now all I've simply done is just go output 1 is injector 1, output 2 injector 2, etc. So they're simply numbered exactly the same way as the cylinders would be, and with the top dead centers in the engine details, that will all just work the way we need it to. Okay, the next thing we have is our injector type. Now there's a few different sort of details here that I'm going to go through. So it basically includes the type, the injector peak time, the hold current and the peak current. So if I use this drop down menu here, you'll know I've got 3 different options. Now these 3 options are how does the ECU use its output to drive these injectors. Now the same with our earlier ECUs, there's a difference in the injectors, like from whether we go from high resistance or high ohm injectors to low ohm injectors. We also now have a third output type, which is the extended peak and hold. Now I'm just going to go back to my PowerPoint presentation here just to give you a quick refresher course on what we're talking about here. When we talk about saturated injector drives, now these injectors are high resistance, so if you get the multimeter out and measure the resistance across the 2 pins of the injector, we're generally in a range of about 8 ohms right up to 16 ohms. Most of the modern cars will be about 12 to 16, but some of the high resistance aftermarket injectors are getting down to about 8 ohms. Like anything lower than that and it's not a saturated injector. So effectively all the ECU output pin does is simply when we're off, we're at a high voltage, which will be your battery supply, and the ECU simply turns that on to ground so that the current flows. The injector will build its current and reach a current limit and go along until we turn it off, and then the current will decay. Quite simple. If we move on to our peak and hold injectors, what we do here is something a little bit different. These are generally lower ohm injectors. So we're talking about 0.5 ohms up to about 5 ohms. So the earlier style motorsport injectors were generally like of a lower resistance type. So we actually have to drive them a little bit different. Otherwise, you'd build up too much current in the ECU output pins, and that creates heat and all kinds of problems. So by the injector having a low resistance, we actually need to control the current a bit. So quite simply, what we have is we have a peak time where we simply turn it on and allow it to build as much current as the injector is likely to. And what we do is we have a peak current setting. Now, once the ECU reaches or notices that peak current is reached, it will simply switch the drive of the injector output to be a very high frequency pulse width modulation. Now effectively what that does is that lowers the amount of current that the injector sees. It's already open, so to hold it open you actually need less current. So basically this ends up being roughly a 4:1 ratio, generally speaking. Some weird injectors can use sort of different amounts of peak and hold ratio, but generally about 4:1 is what we'll be using. Now we have, for purposes of error detecting, we have a fuel injector peak timer. So that's basically a fixed time that we set, and what we're hoping is that this injector will build that current, or the peak current we're looking for, before the timer runs out. If the timer elapses and we haven't actually reached peak current, the ECU will still drop down to the hold current and go along as normal from there, but that's when we'll get a warning that something hasn't gone quite right, even though the injector might still fire. You might have to either adjust your peak current setting, or realistically most injectors would have come here to be characterized, so we can actually supply you with the details anyway. But if you get some kind of wiring problem, say, or the battery voltage isn't good enough supply to the injector, then you can run into problems that way. But basically, with the peak time, we're assuming that we're going to get there before the peak time runs out. Now with our extended peak and hold injector drive, now these are still low resistance injectors, but what we've found is some of the really large capacity injectors that are used in motorsport these days can take a very, very long time to open. So in the past what we've had is special modes in our earlier ECUs just to sort of give these injectors a bit more leeway so they can have the peak current for a lot longer time. So what we're saying here with this injector is we actually use the peak time as a way of letting the injector get to its peak current and then still holding that current until the peak timer runs out. So the idea is we still want it to get to the peak current before the timer runs out, but the ECU will actually hold that peak current until the timer fully runs out, and then it will drop it down to the hold current. So this is a chance to give those big heavy injectors time to open and absolutely make sure they open, because you can get the bounce on the pin tool where they open and sort of flutter around a bit. So what we want to do is keep plenty of current term to open them and make sure they're definitely opened. Now if I just go back to my M1, you can see here we have our peak time. I've got that set at about 3 milliseconds, which is probably about right for the injectors I'm using. On my particular engine it is a saturated drive, so the hold current is my recommended 0.3 amps. The peak current in the case of a saturated drive is quite simply used as more or less error checking. If it actually went to 4 amps with a saturated injector, I would get a peak warning. So these three settings here, and also the injector type, realistically, if you have an injector tested by us, we will provide you these numbers. So realistically they should be set per injector. Okay, now the next thing we move on to is what we call our injector linearization. Now this serves quite an important task in the ECU. Now I'll just go back to my PowerPoint again to give you a bit of an explanation of how this ECU actually works. What we're doing here is we when we are tuning this particular ECU, because of the efficiency based model, what we are tuning on the dyno is the air volume. So what we do is when we tune it, the ECU is able to work out what air volume is going into this engine. Now we specify as a tuner what is the required fuel mixture or air fuel ratio or lambda. We also have some compensations for maybe engine temperature, air temperature and things like that. So they go to combine to give us a mixture aim, or what is the air fuel ratio we actually want. Because we've tuned the air fuel volume, what we now need to know is for that amount of air, given this mixture aim, how much volume of fuel do we actually need to squirt out of these injectors. Now because we know the volume, the way an injector works is the ECU pulses it for a period of time. So what this linearization table is there to do is to convert our fuel volume in microliters through to injector pulse width. So back to the ECU. So what this table effectively does is, for a given fuel volume, what we are actually asking for is what is the pulse width that will give us that volume. Now it's also based on battery voltage supply to the ECU, because if we use lower voltage it's going to take longer for the injector to open and therefore we'll get less volume. And it's also based on the differential pressure across the injector. So this is where your fuel pressure sensor would come into play. So this is quite important to have this table completely filled out correctly for your injector. And again, if the injector has come to us to be characterized, we will supply all this information to you. So if you put that into the ECU knows exactly what it needs to do to that injector to give the amount of fuel volume that you've requested. We also have a couple more details here, and what we're talking about here is we've got a reference flow and a reference pressure. Now again, just back to my PowerPoint, I have a bit of a diagram here. Now this is more or less one run of the test we would do for an injector. So it's at one pressure and one voltage. What we actually do is we vary the pulse width and measure the actual flow. Now the way an injector works is it will always have a certain amount of time where you can pulse it and you get no fuel. This is commonly called the dead time. Then we also have a non-linear region where the injector's just sort of cracking open and we do get fuel and it's quite repeatable, but it's not quite linear. Then we open up to a linear flow region where if you simply double the pulse width you'll get double the amount of flow. Now all of this information has to be contained within the ECU. So the injector linearization table, the main purpose of that is realistically to give us a really good accurate view of this non-linear region, because we know past that non-linear region it is actually linear. So if I just go back to my ECU, so realistically this table here only needs to cover the non-linear region of the injector. So that's what we've been doing lately. We've been shortening our test. It also means we have to spend less time and we don't need to get many different points in the linear region because it's simply using up our time. So to compensate for not using the table for the linear region, we simply tell the ECU at maximum flow what is this injector going to put out and what was the pressure we did that at. So all we're saying is we're using some trick mathematics in the background to work out what this maximum flow will be at different pressures. So you only really need to put in one reference flow and one pressure. This will be based on your particular injector, as I've been saying, and it will also be on the same sheet of that the linearization table will be on. So all of this information from the currents, the linearization to the reference flow and reference pressure will be provided by us. So send your injectors in if we haven't already done them through one of your local MoTeC dealers and we can test them and give you a full data sheet. There's also one last sort of parameter for the injector characterization, which is more or less what is the minimum amount of volume we're likely to get out of this to be repeatable. Realistically, we'll probably give you advice on that, but I've got 1 microliter for my injectors. So again, that sort of information can be provided by us as well. So you basically just need to have your injector tested and we'll provide you all this information. The last couple of items that I want to make everyone aware of are the timing limits. Now again, if I just go back to my PowerPoint, what we are simply talking about here is I've got a bit of a linear graph here, which if we consider this top dead center firing of the cylinder, I've also got 180 degrees before top dead center and back to 360 degrees. What we've always done in the past is we've had what's called an end of injection table. So what we're talking about here is if this is my fuel pulse, I'm going to give it a end point, so which says the ECU will calculate when to start firing the injector to make sure it gets the full pulse in, and then also have that pulse finish at a specific angle before top dead center. So obviously the valves are closing. We don't want to sort of try to squirt fuel when a valve is closing. So what we've done is we've got this end of injection table. I do have another parameter now, which is a fuel timing limit, and what we're effectively doing here is we're giving an overall limit to when is the last point that fuel will physically go into that cylinder. So if you think about the camshaft timing, at some point the valve is going to be shut. Squirting in any more fuel after that point is going to be serve no purpose. It's going to sit around in the intake manifold and have to wait for the next injection event. So we've got 2 tables now. So those are the injection timing, which everyone will be used to. It's the same as our previous ECUs, but now we have a fuel timing limit, and I've simply got that set at about 170 degrees before top dead center. So after this point, no fuel can be injected. So if I just go back to my PowerPoint, the one thing you need to be careful of is if you set a fuel timing number lower than your fuel timing limit, the ECU will not inject that amount of fuel. So you have to be careful of them crossing over. Now realistically, most engines, these 2 points where the valve closes and where you want to finish injecting fuel will be quite far away. But I know some of the motorsport engines that I've seen, people have got various different ideas of how they want to run it. So we just have to be a bit careful here. So just be aware that there's a timing limit and you've got the timing table which you can mess with. Don't have the 2 overlap because you will lose fuel. Okay, thank you for watching this webinar. As always, this will be up on our website and also on YouTube, so you can search for these at either point. Also, if you have any questions that are possibly after hours, you can also join our MoTeC forum at motec.com. There's plenty of people around the world who are usually on the forum who are smart enough to be able to answer your questions. We also keep an eye on this just to make sure all the information is correct. So thank you, and I hope you can watch more of our videos.